The deadlock is a situation where two or more threads are blocked forever or may wait for each other to complete their functionality. It may occur where multiple threads need the same resources at the same point of time but obtain them in a different order. So, any Java multi-threaded program may suffer from the deadlock situation because of the keyword synchronized that we use for the thread synchronization. So let's review our code. And this code shows you the situation of deadlock. So two objects, lock 1, lock 2. Mm, and then two threads are created, T1, T2 of the thread demo 1 and thread demo 2 type. And here, what am I trying to do? Yeah, let me just take you through this thread demo 1 class. And this is our thread demo 2 class. So both of the classes, they are extending the thread keyword. And here two objects are created and they are calling the start methods, and those start method will lead them to the respective run method. So the T1 object will invoke this run method and T2 object will invoke this run method over here. So let's see what do we have here. In this demo 1, for the T1 thread, it's locking the resource uh, with the object lock 1, and these are certain statements that we are waiting for to be executed. So, and this is the rest of the code for the thread demo 2 class. So let me just show you one thing. When I run the code, you can see the thread 1, it's holding the lock 1. So first, when the T1 thread is starting its execution, so T1 is holding the lock. Then T2 will start its work. Thread 2 will hold the lock. Okay. Now here, yeah. So here in the try method, in the try catch block, the thread is going to sleep for 10 milliseconds. And then after that, it will wait for the lock 2. So T1 wants the lock 2 right now instead of lock 1. And then by the same time also, the thread 2 will wait for the lock 1. Okay. So T1 is waiting for lock 2 and T2 is waiting for lock 1. So while the T2 is waiting for lock 2, the thread 2 is locking the lock 2 and it's sleeping right now. So it has not completed its work yet. So now the thread 1 which wants the lock 2, the thread 2 is holding that. So thread 1 might not be able to access the lock 2, the same resource which the thread 2 has right now, and the thread 1 has to wait for thread 2 until it completes its work with have access to the lock 2. The same thing goes on also for the thread 2 as well. While thread 1 is holding a lock on the first one resource, at the same point of time, now thread 2 wants the lock on the same resource on the lock 1. So it's kind of a deadlock situation. So as you see, the process is still going on and it's not stopping. It's a deadlock situation. So how to recover this type of situation? So if in a certain way we can change the code in a certain way so that the thread 1 when it will hold the lock 1 and thread 2 while it's holding the lock 2. So next step, thread 1 and 2 should not wait or want the same resources which are held by their opponents in the next hand side. So if you can change this ordering of this synchronized lock 2 and synchronized lock 1, so that will be a different situation, and that is our solution to deadlock. So let me show you it to you here. Everything is basically similar. These are the two locks and two threads created, and here if you see lock 1 lock 2, yeah, so in the first class thread 1 where we have the deadlock situation, first we are having this synchronized lock 1 and here it's synchronized lock 2. In the next in the solution of our deadlock program also we have the same ordering, but what I did in the for the thread 2 I'm going to change this ordering. Instead of this I'm going to change it to this one. So while the thread 1 is holding the lock on 1, so thread 2 shouldn't wait for the lock 1. So the thread 2, it will first invoke this statement, okay, then this statement. I just changed the ordering. So what will happen now when we run the code? Okay, first thread 1 is holding the lock, thread 1 is holding the lock 2 right now, and then waiting for the lock 2, and then thread 1 is holding both of the lock 1 and 2 and do its own thing, or do its processing. Now after the thread 1 is done with both of the resources lock 1 lock 2, now the thread 2 will start its work with lock 1, then it will wait for lock 2 and will hold both of this. Okay, so now we recover the deadlock situation and it's our solution. So that's why you are seeing the lock has been obtained in a proper sequence by both of the threads, and both of the threads have successfully completed their work without any deadlock situation occurring.